Alright, so today we will be discussing something around DevOps, not completely diving deep into DevOps, but starting to get some glimpses of it. So, after the last video, I got few of the comments and few of the reviews that most of the content on YouTube is related to building these apps, building web apps, building MERN stacks to be very precise. So I thought of why not discuss with you guys. So it's around midnight, and I'm recording this video because I was working on a project which demanded me to learn a lot about scaling things up, demanded me to learn about how to deploy these applications, how to manage databases, and all those things. So obviously at a very beginner level, which I have started with initially, no one knows what Kubernetes cluster looks like, what GCP provides you to deploy, what AWS provides you to deploy, what containers are basically. So to tackle all these, I have got through a platform called as Render, which we would be using in this video to basically try and deploy a web app. Directly deploying the web app would be completely upon you. I would be attaching the documentation in the comment section. If you want to access, you can directly go, or you can jump onto the site's uh, documentation, and you can get through it. We would be more focusing according to few of the terms which you would be uh, confused about, few of the concepts which we would be learning uh, on a very basic level. I would just want you guys to be familiar with few of the concepts which I would be addressing right now, because I personally was stuck on these concepts when I started to deploy my first app. Okay, so initially I have deployed my apps using Netlify, using Heroku, but I personally feel that what Render, or basically VPS has, uh, can't be learnt from something like Netlify, wherein you just drag and drop your files randomly, the CDNs are built up, the dependencies are got through, and we are up. Okay, so herein what we have is not discussing about the technicalities of what API I have built through, but more focusing on the deployment part. So few of the questions which I have compiled today, uh, what deploy is, I guess we have covered it. So basically moving the localhost application to a server wherein it can be accessed by thousands of users. What is inbound and outbound, how to expose ports, what are secure IPs for DBs, scaling up things without using YAML and Kubernetes. So I would be addressing what a few of the terms here, which might not be very much familiar for all of you guys out there. But yeah, starting, so just to give you a very basic understanding which we have. So we are using Mongo Atlas to store some data. What data, what logic, we would not be discussing here. The prerequisites which I personally would suggest you to at least know few of the most concepts, that we have a database on Mongo Atlas. We have a API which we deployed on Render, Netlify, whatever you want to. We would be using Render here, and then a front end service. So a very heads up, or a small point to be noted here, that when you might see few of the architectures, you might see that the front end and the API, or the backend part, both are clubbed on a single instance, and only the front end is exposed, and the front end is talking to API in a local host manner. So basically, maybe the API would be exposed to something like port 5000, and the front end would be exposed to something, let's say, port 8080. And this 8080 port would be exposed to the public internet, and the 5000 port would not be exposed to public internet, only the front end could access this. Okay, so we are adding up a layer that, yeah, only the front end can be accessed through the point 8080. How would you do this? We were talking about some DNS records. uh, we have CNAME, we have A, we have AAA, so all those things, you can explore those through documentations. I will documentation would provide you a more better insights through it. But yeah, talking about inbound and outbound traffic. Okay, let's first start with the deployment part, but just to give you a very glimpse of what inbound and outbound traffic is, because this is something where many of the beginners are losing their money out. because the services which are out there like AWS, Render even charges you for the bandwidth which is for the outbound traffic. Okay, so initially this was not here, right? So what it means, what we were having two instances. When we mean instances, those are basically some random servers which we would be using right now. So I would be first logging into the render platform and showing you a few things. So this would be same for everyone out there. You can spin up your instances at free whenever you want to. Okay, so see, I have two of the instances running right now. How to do these, how to run these instances? uh, Go to the new, then we have multiple things. If let's say I want to go for the web service, to create a new web service, uh, so these are the GitHub repositories which I have allowed the access for render to access from my GitHub account. Okay, so you can change the access policies with the options which you have. Let's suppose I want to deploy one more instance of skill contest which I have right now. uh, and it would ask me what the name looks like, what are the build commands. Root directory is default for me. Build command might be, let's say, npm I, and if there are some depreciated dependencies or depreciated packages which I'm running, it should be npm if or something like that, right? And start command might be node index.js. It depends completely upon to the what the developer wants to do. This is a very basic command which you want to do. Every other thing will be taken care of by render. So initially, if you are directly using a VPS on AWS, you have to configure it. You have to install some dependencies like node engines. You have to install dependencies. If you're using Kubernetes, if you're using Docker, you have to install that. So all these things are taken care of by render. So this is the additional wrapper kind of a thing over the basic VPS which render provides to us. So it's quite beginner friendly to us. And once you're ready with this, you just deploy the service. Okay, I'm not deploying it right now because I already have these services running. So these are paid services for me, but you can spin up your free instances as well. Okay, so if I try to open here, basically all of the code which I was running on the local host is now migrated to the server which this render has on this particular URL. Okay, we have multiple more logs, we have shells. I would coming on to what exactly these things are. So what I'm trying to explain to you here is, right now this front end is running on a different service, this API is running on a different service for me. So whenever two services or two instances try to communicate with each other through public internet, which is happening right now for my services, which is not advisable because this creates a extra outbound traffic bandwidth to us. This gives you some extra charges. And let's say now I club both of them into single repository and ask my front end to query a localhost 5000, which would be only exposed inbound. Inbound means basically adding just a wrapper over here. Okay, this now is a single instance instead of two different instances. These has some more pros and cons of its own. These are architectural issues to be solved uh, with the engineers which are building this particular software. So we will not dive into what good what bad is. I am explaining you both the scenarios. So if we club front end and back end in a single instance, it would create less outbound bandwidth because the more talking between the front end and the back end API is through the inbound, that is the local host traffic, right? And we have a database installed on Mongo Atlas. We can also install MongoDB on the same instance here and instantiate this, but in that case we have to persist this data. So we have something called as persistent disks, which also have some additional charges. But I'm just trying to introduce you a very basic web flow. Initially, what I used to do is deploy front end on Heroku, deploy backend on Render, and database on Mongo Atlas. All the services exposed publicly, which gave me a very high bandwidth. Obviously, the cost increased a lot for me, and it's not obviously safe because I expose my database to each and every IP. If we know what is public listing, what is private listing, all those things. We would be moving on to what how to do those things also. But yeah, So what I'm going to do now is just to go to the render platform and show you how these things work. Okay, I have some connections of deploying latest commits, restarting this service. So once I click deploy latest service, the entire process happens on its own. Okay, the important thing which I want to show you is about the blueprints. Okay, so I've not created a blueprint yet. So what happens is, if you know something about Kubernetes and Docker. So Docker is basically a container, which means basically we package the entire code of our Node API into a single container, which is based upon, not directly based upon the OS. It creates a more abstract class kind of a thing over the OS, but under the hood, all the Docker containers do use the same kernel. I know that this is quite heavy if you are starting for the first time, but all these concepts are to be learned through learning Docker, learning Kubernetes. You would not dive there, but I would be tackling what kind of issues these things solve. Okay, so now let's suppose I have this particular API running. Okay, in my case, I am not using inbound traffic. So now what happens is, let's suppose my particular API is good to use for 100 200 users at maximum. Okay, now what happens is 10,000 users are hitting my websites randomly because there is some kind of sale, some kind of event which is happening on my website, which in turn increases the bandwidth, and now this particular instance can't handle the 10,000 requests. So what we do is basically we try to multiply these instances and do it something like this. Now let's suppose I'm deleting this right now. So I'm having 3 instances right now, and now this particular front end has to talk with all these APIs according to the traffic which we have. So we have something called as load balancer sitting right in the middle. Okay, so we have Nginx for it. We have Kubernetes inbuilt load balancers as well. So all these things needs to be configured by you as a DevOps engineer if you want to have systems at scale. Okay, and this load balancer sits in between. Uh, no need to have these things. Load balancer basically is sitting in between. It has something called as round robin format. It has some weighted round robin format things and all those. Basically, trying to distribute the kind of traffic to each and every instance present right now. So this might be done by the Kubernetes cluster itself. You might be using something like Nginx, which I previously mentioned. So these all these things need to be configured by you as a DevOps engineer. But here is the main USP of render which comes here. Obviously, it's not something kind of a sponsor thing, but I love this platform a lot because I used it personally and got to know about it when I was trying to surf through. I'm not aware of whether REST platforms also provide these same things, but render does. If you try to search on net about render scaling, so the render basically scales these systems for us. Okay, so all these things about configuring load balancers, instantiating Docker containers, container orchestrations, you use something called as YAML for all these things, and you need to install some more dependencies for that. That is a whole different branch if you go into software development, so it is completely out of scope for this video. I am also learning these things, and trust me, it is very very interesting. Theoretically it's really interesting, and more you dive deeper you get more insights to it. But obviously nowadays you don't sit and write YAML. Instead you go on to AWS, you go on to GCP, they have their own clusters deployed. We do use them always, and render is a very simplistic solution of that particular thing which we are looking forward to. So what render tells us to do is basically we have 2 types of scaling: manual scaling and auto scaling. If you want to scale manually, we would be putting up the total number of instances from minimum to maximum. Uh, and let's suppose the case which scenario which I introduced first, right? So let's suppose I am planning to have somewhere around 3,000 users, and my single instance can cater up to 1,000 users. Then I would be changing a few of the settings in my render account, wherein I would be telling that telling the software to basically scale up my number of instances whenever my single instance is utilized for more than 80%, let's say. So if my this particular instance is running and now 80% of the CPU is already used, then I would be spinning up the another container. And now let's suppose this also is 80% more, I would be spinning up another. So this is the thing which is used during horizontal scaling. So we have two things in scaling: horizontal and vertical scaling. So during vertical scaling, we basically try to increase the specification of the server. We increase the RAM, we increase the type of CPUs which we have. Let's say we had uh, 30 core CPU, now we are moving to 60 core CPU. We have uh, processors like AMD Threadrippers, which have 30 32 cores, more than 60 threads. So we try to basically have more and more of that cores, more onboard RAM and all those things in vertical scaling. But in horizontal scaling, we try to add up these instances so that we have multiple instances and not a single point of failure. So I'm just trying to bombard you with all these phrases so that you try to explore it more. And the basic use case is to try and scale up all these things, because no software can generate revenue if it is to be used only by 200 to 300 users. We need millions of users. Google serves billions of hits per day. So these systems are very robust in nature, and if you want to start and get a very brief essence of it, Render is a very good platform to start with, I suppose, because I was struggling a lot to build a software which would scale up to these kind of users. So right now I am catering about 2 to 3,000 users for my project. Obviously, it also very initial levels. Once it's once I think that it's really at par with my expectations, I would making it public to you all guys also. So they have also mentioned about few formulas, how they create these instances, what the current utilization process or the percentage they look up to. Let's suppose my target CPU 60% and current I am at 80%. Then how much instances should I spin up to reduce this number to less than 60? So all these calculations are done by Render's algorithm internally under the hood. We need not look forward to it. But if we hadn't use this particular thing, we had to use something like Kubernetes clusters. So these also do the same thing. I just tried to give you the essence of why we need load balancing. Now I'm just moving around with all the features which I personally think that would be of your use, because I want to what want you guys at a very beginner level only to explore this platform, because almost other platforms would give you the same kind of things but not at very cheap or free levels. Okay, another thing. Now let's suppose I have deployed my instance, just uh, just like this. Okay, so I have this particular thing, but whenever I click connect here, I got some outbound IPs. So these are the IPs of my server which my particular code is running onto. Okay, then how to map this particular URL or particular IP to my domain, let's say. So I had purchased a domain few days back, and this is the hostinger DNS configuration settings. So let's suppose now I want to, this is the UI which I had deployed. So I have basically changed the DNS record name to basically whenever, let's suppose a judge is a subdomain. So I am building a website somewhere around competition websites wherein a user can put entries to compete, and there are few judges which would judge that entries and then give the final results. So I had this subdomain called as judge dot then my main domain. So that particular main domain is routed or is configured to hit this particular IP or this particular URL on render. So these are the DNS configuration. There is something called as time to live. So I'm just trying to give you the glimpses of how this entire process look like. So first of all, we deployed it on render using our GitHub. We gave access of our GitHub repository to the render platform. Render brought in all the files from our GitHub, configured it along into dependencies and started to run our API. Then we configured our DNS servers to basically map each and every request from our domain to the render's IP address. and then each time we hit our domain, our render would in the end cater all the requests. Okay, I have also created some backup bash scripts to back up every time we have to. So because we have a lot of data now, I would just open my terminal once. I would show you what I'm going to do now. Okay, just give me a second. My screens. What now I'm focusing is to try and connect my virtual server to through my terminal now. We can obviously click here on the shell and then we would get the shell right here, but I don't want to do that. I want to access this particular VPS through my local terminal. So yeah, this is something which some logs which I have done. So I've also tried and implemented logging using Winston. Winston is a very popular library in Node to basically log all of these things. So yeah, starting with connecting. So I have this SSH key, SSH. I always fumble around with pronunciation of SSH. I would rather call it secured cell. Okay, so what I'm going to do is connect to the remote server through my local machine. So what is happening right now is first of all you have to generate some SHA keys which are called authorization keys. So I have also added a passphrase to it to basically make it more secure. So I am now logged into the remote server. So basically whatever I enter here as a command, the process would run on the VPS and the results will be shown here. So now let's suppose, yeah, so I'm just trying to access all the files here. So I have a backup file, I have a log file just to store all the logs in case my API fails. Then I have all the logs which all the activities of the API which happened for the last 24 hours. So I have all these things. If I want to open index.js, I can do it. So this is something somehow which looks the index.js file. I have multiple things to show you. We have backup. So backup file is just to show you that whenever I run this particular bash script, all my MongoDB data is backed up to a GitHub repository. So this is just to show you how to log into a remote server. I'm just exiting this to get to my local machine. Cool. Yeah, so now what I'm going to do is try and go to Mongo and show you why I have not tried and listed all the IPs to access my database. But before that also, if I guess the scaling part for your side is clear just in a way that why we need scaling. Okay, so there's something called as auto scaling wherein these things scale up with on their own. For manual scaling we do need to add the number of replicas which you want to scale, but for auto scaling we have some different combinations of compute percentage used in all those things. You can read up these things. So Render has a very good documentation. These are obviously scaling is a premium feature, but you can read and take the very crux of it to be that how this would be implemented at the backend part, because under the hood they would be using YAML files. Okay, so they would be creating blueprint of your or the images of your API, would be deploying it to Docker hub or some hub of their own, and then pulling that images to the Kubernetes cluster. Okay, if you want to explore more, you can go to Minikube. Yeah, so Minikube is something it's like a simulation of Kubernetes at a very smaller level. I'm also having Docker installed on local, but I would not dive deeper because this video would go long and long. I can talk hours about this particular thing because Docker is something which makes our lives really, really easy. Obviously, render would work, but in corporates, no one would go for a third-party service to handle all these services, right? So there, you have to take on VPS from platforms like AWS and GCP and then configure each and every part of it through Kubernetes and Docker. But the main crux is basically want to scale systems to make it more reliable. Let's say your one of the instance fail, then the entire app would fail, right? Instead, you would be having multiple instances running. So even if one fails and it's being reinstantiated at that particular time, rest all would serve the needs. So this is why we need Kubernetes and Docker. So Docker is something just to containerize and to orchestrate. So we basically call Kubernetes a container orchestration. Okay, so I'm again moving on to the more complex things. But yeah, if you want to refer, you can always refer the documentations. I'm a big fan of the documentation. Minikube, Render, and Kubernetes have really, really good documentations to work upon. You can go there and read day in and day out, and still you would not be able to read even 10% of what exactly these things are. Okay. So I've talked about deploying to render, I talked about scaling a bit. Yeah, now the next thing is about databases and how to uh, basically use the IP locking and whitelisting of APIs, right? So let's move on to that. So we have logged into the Mongo app. Now if so this is the cluster which I'm running right now. There are a few data coming and going all around. I'm still on free tier. I'm having more than 1,000 or even 2,000 documents which are being stored, been written, been updated through, but still Mongo is doing it really well in the free tier also, because I'm dealing more around textual data. I am not having any kind of blob data, images and all those things. So we have two main things here: network access and database access. So under database access you can provide URLs. So I have one admin and I have one tester. So in the network access, this is the thing. So I went across these things right around render, that when you try to connect in the outbound. So again, outbound is basically to the public uh, to the public net, right? So these are the IPs, and these IPs are through which one of these IPs would be accessing our database. So I have added all these IPs here to basically get and allow our uh, API to get data or put data or to delete data from our Mongo server. Okay, so if you want to dive deeper onto IP address, we have classless inter-domain writing (CIDR). We have something called as subnetting. If you are using geofence networks, if you want to restrict your IPs to a specific set of or cluster of IPs only to in your corporate organization. So there are many more things which would be there to talk about IPs. Just in that case, you have to learn a lot about computer networks. So there is a lot to explore these things also. But my main thing here, let's say you want to add IP address and you want to allow every particular IP to access. If you're on testing phase, you can allow access from anywhere and confirm. This would allow you to access this Mongo cluster from any device of your choice. But obviously, if you're in testing phase, it's okay to do that. But if you're in production, you have to delete this and stick to the only 2 to 3 IPs which your API would be using to access our Mongo. So I've tried to cover all these things about what inbound, outbound IP is, how to secure IPs for DB, how to scale up without using YAML. If you try to search about what exactly YAML file is for, let's say, Kubernetes, and I might be, so this is something which, okay, so this is how the YAML files look like on a very basic level. We have API version, guide, metadata, and spec as the root level entities. We would be having some child there. So these are some kind of arrays. We have notation. This is a completely different language or a script, I would say, which is actually really, really handy if you know how to use it. So instead of that, we are using a UI. on render to configure all these things and generate blueprints out of it. Even if you want to generate blueprints through render and then use it to push to Docker Hub and then use on your Kubernetes cluster, feel free to do so. This is also possible if you want to do. But yeah, the main mode of the video was to just give you a very high level exposure to how DevOps would look like, how interesting it is. It might sound very difficult initial level, but once you try to dive deeper and deeper, I personally have spent hundreds of hours in past few months itself to learn these things. I'm trying to get some certifications out of it. But yeah, it's really cool. If you want to learn Kubernetes and Docker, I would be bringing on some more videos through it. Let me know if you want to learn some specific topics as well. I'm more kind of a backend guy, not DevOps. I've worked a lot on Spring Boot and Node, and now I'm trying to learn something around DevOps. So yeah, cool. That's it from my side as of now. I feel this video and past few minutes have added value to your knowledge base. Thanks a lot. Would meet you in the next video. Bye.